296. Okay, so we're going to have a look at factorising a quadratic when we've got more than one x squared. Okay, so if now there is a method that they give you which is kind of a trial and error method to some extent, but we're going to go through a different way, and it's called factorising by splitting the middle term, and it's very similar to what you've done in the past but with like 1 or 2 extra steps. So, for instance, if we're asked to... Are you done?
Yes.
I just had one question.
So, yeah, let's factorise one where if we're looking at a x squared plus bx plus c, we're now looking at where a is not equal to 1, basically. So if I said factorise 2x squared plus 5x plus 3, okay, so our normal method for factorising is to look at the numbers and say, right, we've got 2 sets of brackets. How do I know there are going to be 2 sets of brackets, by the way? Okay. There are 3 terms and there is a square. You're right, and there are 3 terms, but also that there's no common factor to all 3, okay? So I look at that and I think, well, I can't take a common factor out, so it must be something else, and like you're right, because there are 3 terms, I should be able to get 2 brackets. If there were 4 terms of differing degree, we should call them, how many brackets would I need?
Still 2. What do you mean of different?
4, oh, good question. What do I mean by different degree?
Like x cubed plus x squared plus x plus 3.
Yes.
Oh, okay.
So the degree meaning the powers. Yeah. So this is a power 2. This is a power 1, and this is a power 0.
This is power 0. Isn't everything that's power 0 1?
Exactly. So if I say x to the power of 0, that means 3
Oh,
times 1,
Okay.
which is just 3. So we don't write it. Yes.
So, the amount of brackets needed are the exponent of the first.
The highest degree, yeah. So if I've got an x to the power of 5, okay, as long as I have an x to the power of 4, 3, 2, all of them, then I will need 1 less. Yeah. Okay. Right, so this time then, because normally what we say is we look at it and go, right, 2 numbers multiply to make 3, add to make 5, yeah? What we tend to do. It doesn't work in this case, does it? Because what multiplies to make 3?
3 and 1.
3 and 1, that's it, it's a prime number. 3 and 1 don't add to make 5. But,
There's a 2 in front of the x squared.
and that does have an impact, doesn't it? So now as soon as we don't have 1x squared, that x squared, the coefficient of x squared comes into play when the rest of it. So we have to do something else. So the method that we could do, which is what they say in the book, is, well, actually there is only one way of making 2x squared, which is 2x and x. All right? And the only way of making 3 is 1 times 3. So, and it's positive, so it could be negatives or positives, but we've got a positive in the middle, so they must both be positive. So this one's quite an easy one to do. It's a kind of trial and error approach. Which bracket, which number goes in which bracket? That's the trial and error. What do you think?
The 1 goes in the right bracket, so the 2 to multiply with it to make 5.
Okay. So 3 lots of x makes 3x, 2 lots of 2x, or 1 lot of 2x makes 2x, it does make 5x. Okay, so it's nice and simple. All right, it is easier, and when we've got a prime number in the beginning, it's much easier to do. All right, but it's not always going to be that simple. So what we're going to do is we're going to look at a method called splitting the middle term, and we're going to do it with this one so we know what we should get. So again, I'm going to start with x squared plus 5x plus 3. And what I'm going to do, this whole 2x times 1 and 3 times x, because this now gets involved, what we need to do is figure out how it is involved. So my first step is now I actually multiply the 2 and the 3. Okay, so I'm going to multiply the 2 by the 3 and I get 6. Now what I'm going to do is I'm going to work out two numbers that multiply to make 6 but add to make 5.
2, 3, and 2.
Okay, so I've got 2 times 3 and I've got 2 plus 3. And we use this number now to split that middle term. All right, so we've just used this 6 to find those two numbers, and that I can forget about it now. I don't need it anymore. All right, but I'm going to split the middle term. I do it like this: 2x squared, and then I say it's plus 2x plus 3x plus 3. All right, so I've split my middle term into the two things that it needs to be. Does that make sense? That's why it's called splitting the middle term. Question would be, does it matter which way round I write them?
No, because they're all adding together.
Okay, so it doesn't actually matter. And then what I do, go on then, Ethan.
I have a question.
Yeah.
About like how come it's like 2x and then plus 3x? Couldn't it be like 2.5x plus 2?
No, because we're dealing in whole numbers whenever we're trying to factorize, we're dealing in whole numbers as much as we can at the moment. Yeah? All right, so what I do now is, me personally, I put a little line to signify I'm now splitting it up. And I'm going to factorize those two parts separately. All right, so if I factorize this half, what do I get?
2 bracket x squared plus x.
Almost.
2x.
Good.
Oh.
All right, now I'm going to factorize this side. Is it positive 3 bracket x plus 1? So here's a clue to you being correct. Both the brackets should be the same thing. If they're not, we're going the wrong way. Right? Now I have to factorize again. And we did this the other day. So how can I factorize this?
2x plus 3 brackets then x plus 1.
Yeah, so the common factor I've taken out is the x plus 1. So I can write 2x plus 3 brackets x plus 1. Okay. So I've now factorised it through splitting the middle term. And you'll notice I get the same answer, which is nice. Right, yes?
We'll be able to choose which method
Yes.
to do.
The only reason I say this is because sometimes you get, for instance, if I have 5x squared, that's still all right, isn't it?
Yeah.
Because it's just 5 and 1. Can't do it any other way. If I have 6x squared at the beginning, it could be 6x and 1x. It could be 2x and 3x. So you've got now, and then those two plus all the combinations of everything. So you might be there for a long time. And if you have a look at example 6 in the book, page 297, all right, you'll see their method and you'll see how many attempts they've come across, all right, to get to what they figured out as the correct answer. You see all the red crosses? Some of you are not even looking at the book. Okay? See them all? They've done a trial and error approach. So they've determined that 6x squared can be found by doing 3x and 2x, but they've tried all the options for 3x and 2x, only to get to a decision that actually that didn't work. So then they've gone to 6x and x. Do you see that in the list, yeah?
Mm-hmm.
So let's try it instead with the splitting the middle term approach. All right, so we're going to do 6x squared minus 7x minus 10. All right, so would you like to just do it, or do you want me to talk me through it and do it together?
I would just like to use a kind In a group way.
In a group way, I think that was the general. Right. So you tell me now, what's the first step?
6 times 10.
6 times 10. So we multiply the 6 and the 10, and we get
60.
60. But what is it? It's actually negative 60. So we actually need to think it's got to be a positive and a negative. All right. So this is quite a big one because there's lots of options, isn't there? Yeah. So what multiplies to make 60? But one of them's got to be a positive and one of them's got to be a negative. So we're then looking at the difference of 7. 12 and 5. That gives us a clue, yeah?
Yeah.
Right, so we've got 12 times 5. You're right, could have been 6 and 10, but that doesn't have a difference of 7. See that?
Oh, yeah.
Yeah?
I get it now.
Which one is the negative?
Well,
The 12, because?
it's negative 7x.
So we've got, when we add them together, we get a negative, so the larger one. So it would be minus 12x plus 5x. That make sense?
Yes.
Okay, so I can rewrite it out as 6x squared. Again, I've written it this way around, no particular reason, but I put the 6 with the 12, just kind of makes sense that they go together, and the 5 with the 10. But I could have done it the other way around. I'm going to do it the other way round just to show you it will still work. So I'm going to do the plus 5x and subtract 12x. You okay with that, yeah?
Yeah.
I'm going to split it in half. There's another reason why I've done this. It shows something else as well. Right, factorise this half.
Bracket 6x plus 5.
Okay? Factorise the other half. Ethan?
Negative 2, open bracket, 6x, yeah, plus 10.
Plus 5.
Plus 5.
Good. Great. Normally people forget that there's a negative. They just dump the negative in the middle and then factorise it to be 2 minus 6x minus 5 in the middle. Okay? But you didn't do that, so it's great. And you took the clue that it's the same thing. So then we factorise one more time and get x minus 2, 6x plus 5. Done. And that's a lot shorter than their list of trial and error approach.
What if you do the other?
Alright, let's do it the other way around. Let's get for 6x squared, subtract 12x plus 5x minus 10.
Switch positions.
Yeah, so we get factorise different, but this time we would get 6x x minus 2. Okay? Oh, sorry, I shouldn't have done that.
Couldn't you get 3x as well?
But that's not fully factorised. I want to factorise it fully. If I put 3x, I'd be left with another factor that could still come out. Now it would be plus 5 lots of x minus 2. So I just end up with the other one in the brackets.
Interesting.
Yeah? So it doesn't matter which way round I do it. So I still end up with 6x plus 5, x minus 2.
I'm still not understanding why you can't just do 3x. Because then there would be 3x times x minus 4.
No, it wouldn't.
Okay.
Here, look, it would be 3x lots of
2x.
2x
That's my bad. Yeah.
minus 4. All right?
Yeah.
And it's just not fully factorised. There's still you should always try and fully factorise in this case.
Sorry, my computational drawing.
It's all right? Worth asking the question. Okay, so that's split in the middle term. So, yes, sorry.